Hello everyone, welcome to the session. So in this particular session, I'll talk about that how we can solve any recurrence relation using recursive tree approach. Until now, so far we have discussed that how we can solve any recurrence relation using a substitution method. And I hope that with the help of the three examples or the problems that we have solved until so far, you must get the clarity that how we can substitute any recursive term via a substitution method. Here, let's now talk about a recursive tree approach. This is the second approach to solve any recurrence relation, right? So this is the approach called as recursive tree approach. Okay. Now, in this approach, if you will see, whenever we are talking about a recursive tree approach, it is beneficial only when you have more than one recursive term in a recurrence relation, right? If you have more than one recursive term in a recurrence relation. Now, how basically this is happening? Let's try to understand this part. For example, a given recurrence relation which is given to you is that the value of t of n is something where I am saying, again, when it's a small problem, when the value of n is 1, you can get a constant time complexity. But when the value of n is greater than 1, at that point of time, suppose your time complexity or recurrence relation will be t of n by 5 plus t of 4n by 5 plus the value of n. This is a kind of a recurrence relation that you have. So if you remember, until so far we have discussed about substitution method, and there we have seen that there is only single recursive term that we have in terms of this t. This is a term called recursive term, right? That's what we have understood. Now, how basically, if suppose we are having more than one recursive term, how basically we can solve that? There is only one method with the help of which you can solve, and that is what we are discussing today, recursive tree method. So here if you will try to observe, we are having the value of t of n, and what we are trying to do here is that we are trying to basically dividing our data into basically three parts, I would say. Or in other words, I can say that suppose we are having a n size elements, obviously n is the size of the elements. Now here if you will see, what we are trying to do is that we are dividing our that n size array. You can consider any kind of data structure with which we are storing those n elements, and we are splitting those n elements into two halves. One is the n by 5, another one is the 4n by 5. And the cost required to split these elements into two halves, n by 5 and 4n by 5, is something which we are saying as n here. Can I say this? This is the actual meaning of this statement, where I am saying that we are dividing the complete n size elements into two halves. On the left side we are having n by 5, on the right side we are having 4n by 5, and the cost required to do this particular split is n. Now again, if you will see, the same thing we can do again, but now the way is somewhat different. Here again what we are trying to do is that we are again trying to divide our array into two halves. Now just try to understand the pattern here. When I am dividing my array into two halves, if you will observe on the left side, what we are doing is that we are dividing the array by 5, right? Whatever element we have, we are dividing that with 5. So that is the thing. And on the right side, what we are trying to do is that we are trying to multiply with 4 by 5, or in other words, I would say dividing it by 5 by 4. So again, it will be n by 5 square, or it will be 4n by 5 square. Similarly, here also, on the left side, it will become 4n by 5 square, and on the right side, it will be 4 square n by 5 square. I hope that I am making sense. Just one thing which I am trying to illustrate here is that that whenever we are approaching towards the left hand side, if you will try to observe the picture here, we are dividing or multiplying, in other words, by 1 by 5, and on the right side we are multiplying with the 4 by 5, because that is a kind of a recurrence relation which is given to me, and the cost which is required to do so is n. Now again, the cost required to split this is, if suppose I am splitting n elements into 2 halves, cost required is n. So when I am splitting n by 5 elements into 2 halves, the cost required will be obviously n by 5. And similarly here also it will be 4n by 5. So total cost required in the second level will be 4n by 5 plus n by 5, so it will be equals to n. It will be equals to n. Similarly, here if you will try to observe, again a split will happen into 2 halves, into 2 halves, into 2 halves, and again we will try to calculate the cost, and again if you will do the summation of that, you will get the value as n. Means one thing we are observing, that at every level we are having some sort of cost, but overall in a nutshell, the total cost required will be equals to n. Second thing that we are observing is that when we are moving towards the left side of a recursive tree, we are multiplying our value or our data elements by 1 by 5, and when we are moving towards the right side, we are multiplying the values by 4 by 5. And this is a kind of a recursive tree that we are generating here. This is a kind of a recursive tree that we are trying to generate here, right? Now, the question is again same. Until what point of time do I basically generate this recursive tree? Until what point of time? I have to stop, right? At one point where there is only a leaf node. So, obviously, what is the base case condition? When the value of n is equals to 1 in my recursive tree. It means that when I'm going towards the left side, it will be n by 5 to the power k. When it will be equals to 1, it will stop. It means that the value of k for the left part, I would say, I will say it will be equals to n, which is equals to 5 to the power k. So the value of k here at the left part will be log of n base 5, right? Log of n base 5. Whereas on the right part, if you will try to observe here, on the right part, what we are trying to do is that we are trying to basically getting the value as n by, can I write like 5 by 4 on the below position? 5 by 4 to the power k, which is equals to 1 here. Now here if we will try to solve this, we will be able to get the value of n as 5 by 4 to the power k, and the value of k as log of n base 5 by 4. This is the value of k that we are getting for the right part. Now we all know that we are trying to compute here the big O time complexity, right? So we should know that what is the higher value, what is the higher factor, that only we can take, because if I am taking a higher factor, automatically lower factor will automatically be covered up. If you remember in one of the session, I have already told you that whenever we are comparing a logarithmic part in the complexity classes, I remember I have talked about this thing, that whenever we are comparing a logarithmic part, for example log of n, and there are two bases that we have, for example here we are having 5 and here we are having 10. So a log having a smaller base is having a greater value. This is the major thing that you should know. Again, this comes under the properties of logarithmic, which I am expecting that everyone is aware of as of now. So here if you will see, what is having a lower value? Which base is having a lower factor? Obviously 5 by 4. It means that this is something which is having a overall higher value, right? It means that until k number of levels, how many number of levels we will do split? It will be log of n base 5 by 4. It means k levels. And at every level, what is the cost associated with that? It will be n. So what is the overall time complexity? So either we can do what? We can add until k number of times the effective cost, or now we know the value of k, and we also know that at every level how much cost is required, so we can directly multiply also. It seems like this, that suppose you are having maybe 10 toffees, okay? you are having 10 toffees. So here what I'm saying is that what you are trying to do, that for example, you are splitting your toffees into 5 students, and each student is getting 2 toffees. The number is same. So if you want to count how many number of toffees are there, so what you can do is that you can do it with the help of 2 methods. Either you can count this 2 values 5 number of times, 2 plus 2 plus 2 plus 2 plus 2, and you will get the value as 10, right? Or what you can say to me that why to add until 5 number of times? What I can do is that I have 5 students and each one is having 2 toffees. So I can get the same value as 10 until this method as well, right? Very simple. So what I'm saying is that this 5 is something which you can consider in our tree is the value of k, which indicates that number of levels, right? Number of levels. And this 2 is something which you can consider is the cost, which is the value of n. So either you will add that n until log of n base 2 times, or you can do the simple multiplication. In both of the ways, you're getting the same value. So here, why is that so? Because you are having a same toffees. You are providing the same toffees to everyone. In other words, you are having a same computational cost at every level. That's why you will get a overall time complexity as order of n multiplied with log of n base is 5/4, because that is having a bigger value. So that is the overall result or the answer for this particular approach. So I hope that everyone is able to get an idea that how basically with the help of a recursive tree approach, we can solve any kind of problem. Basically, we have to create this recursive tree. In this recursive tree also, we need to calculate that how many number of levels do we have to create, and at every level, what is the effective cost. Either if the cost is different at every level, suppose here it is n is coming, here some other n/2 or n/4 is coming, here is something n/8 is coming. At that point of time, you need to add every cost until k levels. But here, because the cost is same, so we can directly multiply as well. I hope that I am making sense to everyone. If you still have any sort of doubt, do let me know. And with this, happy learning to all. Bye-bye everyone. See you soon in the next upcoming session.